Merry.
Merry.
Ho, ho, ho! Merry Christmas!
All right, Algebra 2 students, we're back. Mr. Thomas here.
Let's do some math.
Oh, yeah, we're going to learn special right triangles. We had a special gift for our administrators. We can give them a hand. You're watching a video, you can clap. Nobody's going to see you clap or hear you clap, but
They'll feel
a
it.
clap is still a clap. Am I right?
Absolutely it is.
So, also, remember, stay safe this season. Wear your mask when you're around other people. But if there's only a few of you, socially distance.
We can take it off.
And our camera person needs to keep walking. But here we go. We're making it work.
Are you ready to do a little bit of geometric practice to
Practice.
review for 13.2?
You know what? I think that's an excellent idea. All of you, well, maybe most of you have done geometry, so this is something that should be reviewed.
So come on in.
Our very welcoming classroom. We got a nice wreath. I will not use it to break anything, but Miss Collette may break something. We don't know. So,
Who knows?
as we said, we are going to review special right triangles. You'll notice we got a different background. It's orange, and we have a different book, Geometry. This is from Geometry, Special Right Triangles, and our goal is to use the properties of a 45, 45, 90, and a
30, 60, 90 triangle.
so, let's learn about 45, 45, 90 triangles. This is a right triangle. It's called a right triangle because it has a right angle. So, what we can learn about these special right triangles, this 45, 45, 90, is that with a 45, 45, 90 triangle, the shorter sides, these sides, I'm just going to give an example, they're going to be the same length. Now, the side that is opposite the right angle is called the hypotenuse. And on a 45, 45, 90 triangle, the hypotenuse is going to be equal to the shorter sides times radical 2, or the square root of 2. Now, this explains why that is the case. You don't have to know that. I mainly just want you to know that the sides that are adjacent or next to the right triangle are equal, and the hypotenuse is radical 2 times those lengths. So, let's practice. Blue box. Remember, if it's in a blue box or blue words, write that in your notes. So, we have an example over here. The sides that are adjacent are the same, and then you just add, well, multiply by radical 2 for the hypotenuse. So let's look at this example here. We need to determine what h is. You'll notice h is opposite of the right angle, and so that is the hypotenuse. And then I have the shorter side given. It doesn't matter what this is, although I know it's 9. I just need to know that this side is going to be 9, and the hypotenuse is going to be this adjacent side times radical 2. And so h equals 9 radical 2. Now, same thing on this one, except they trick us up a little bit. So I can know that this adjacent side is going to be the same as this one, but x, which is the hypotenuse, is going to be 2 radical 2 times radical 2. So then you say, okay, what do I do? Well, you need to simplify. And if you remember back to, I think, chapter 6 or 7, we learned that if you multiply a radical by the same radical, the square root box goes away. And so, when we rewrite this, we'll multiply it, it would be like 2 times 2, and 2 times 2 equals 4. And so my answer here for x is 4. Let's erase this and look at maybe 1 or 2 more examples. Let's look at one more example. Notice I got the blue box for you. Nice note-taking strategy for you. So I got to figure out what x is. This time, they give us the hypotenuse And so whatever x is here, it's also going to be right there. But this one's multiple choice, but they show you how they go about doing this. They would just enter the formula, hypotenuse equals radical 2 times the leg, which in this case is x. So they just substitute 6 for the hypotenuse, x stays as it is. What they do is they just move the radical 2 to the other side by dividing, that's opposite of multiplication. They kind of flip the orientation of this problem, but you'd be left with x equals 6 over radical 2. Now, you cannot have a radical on the bottom of a fraction, so you have to move that radical to the top, and the way you do that is by multiplying the numerator and the denominator by radical 2. When we do that, we can rewrite the equation. Remember, multiplying a radical by itself, the radical box goes away. This 6 times radical 2 just joins 6 radical 2 over 2. And then we simplify, we can divide 6 from 2. And so our final answer is x equals 3 radical 2, which would be B. All right, that is 45, 45, 90 triangles. Miss Colette, come show us 30, 60, 90 triangles.
Let's talk about 30, 60, 90. Okay, so the reason why it's called a 30, 60, 90 triangle is because in that triangle you have 30 degrees, 60 degrees, and 90 degrees. Like 45, 45, 90, you had 45 degrees, 90 degrees. So in a 30, 60, 90 triangle, it's a little bit trickier, but you guys are professionals, you got it. So the length of the hypotenuse, which remember is your longest side, that's directly across from your right angle, it's twice the length of your shorter angle, okay? Or the shorter leg, sorry. The length of the longer leg is root 3 times the length of the shorter leg. So basically the shorter leg is what we need to find. Well, how do we know which one the shorter is? Okay, it's always going to be the one across from 30 degrees, since 30 degrees is the smallest angle. So we have our 30 degrees, our 60 degrees, and our 90 degrees, okay? So this I would write down, or you can write this down too. Blue, write it down. So across from 30 degrees is our S. That's our shortest leg, and that's always what we need to find in our 30, 60, 90 triangles. So across from 30 is our S, okay? To find the side across from 60, you multiply your shortest leg by root 3, okay? So to get this one, you multiply your shortest leg by root 3. To get your hypotenuse, you multiply your shortest leg by 2. So again, what you need to find in your 30, 60, 90 triangles is always your shortest leg, the leg that is across from 30 degrees. So let's work out a problem. So it says, what is the value of D in simplest radical form, okay? And so simplest radical form means you can't have a radical in the denominator. Just kind of keep that in your mind. So we have this triangle right here. We are looking for D. And on the next slide, we're going to be looking for F. But currently, we're just looking for D. D is the side that's across from 30 degrees, which is what we need to always find first. We are given 5, which is across from 60. Okay, so if we look here, we are given the longer leg. So we are going to be longer leg is equal to root 3 times your shorter leg. Well, that shorter leg, which is D, is what we're looking for. So our longer leg is 5. So 5 is equal to the square root of 3 times our D, right? That's what we need to find. So we're kind of undoing that multiplication of root 3. So we divide both sides by root 3. Cancel, cancel. So our D is equal to 5 over root 3. Okay? However, this is not in simplest radical form. We need to rationalize that denominator. By doing that, we don't want this root 3, so we multiply the top and the bottom by root 3. So 5 root 3 is just 5 root 3, and then root 3 times root 3 is just 3. Okay, we cannot simplify 5 over 3. That fraction is as simplified as it gets. So our shortest leg, D, which is across from 30 degrees, is 5 root 3. Okay, so now let's talk about how to find. We know that this D is 5 root 3. Just going to erase that and erase So now, same problem, it asks what is f in simplest radical form. So we know to find the hypotenuse, we multiply 2 times the shortest leg. Our shortest leg is across from 30 degrees, so all we need to do is multiply 5 root 3 over 3 times 2 to find f. So our f, our longer leg, is equal to 5 root 3 over 3 times 2. Okay, I'm going to say 2 over 1. We know we can't multiply. We have to multiply our big number 5 times 2, which is 10. 3 times 1 is just 3. So this would be 10 root 3 over 3. That's what f is equal to. And that's all you got to do, guys. Okay?
Wow, impressive stuff, Miss Colette.
Thanks. You too, Mr. Thomas.
All right, so like we said, hopefully this is a review for you. If you've never done geometry or you don't remember this at all, this will be helpful. The assignment is actually not even on Math Excel.
No,
It's going to be
it's
a
not.
Google form.
Yeah.
But good luck with it. You can message us if you have any problems.
We are here for you.
We will see you later.
Bye.